Question: what does an educative array do? Answer: it keeps unemployment away. Come again? An educative array keeps unemployment away. Woo! What are we up to next? We have the longest substring without repeating characters. Try to solve the longest substring without repeating characters problem. So given a string, return the length of the longest substring without repeating characters. That doesn't have repeating characters. It could be letters, digits, symbols, and spaces. So here, the longest without a repeating character is B, because everything is repeating. Here it's WKE, because they're all unique. W is unique, K is unique, and it only occurs once in this window, right? It couldn't have been this because W shows up twice. Could have been this actually, because KEW works. Can't be WKEW because W shows up twice. Can't be PWW, pew pew pew. Can't be PW either because there's a longer one, which is this one, and so on and so forth. And if there's nothing, the longest is 0. They return the length, and they're asking us for the length, so it's a number. Awesome. Very quickly, we go through the understand section. Concept of the day. CON is one. ONCEPT is another one. Unique characters, 1, 2, 3, 4, 5, 6 unique characters. Shift it again. NCEPTOF. That's 1, 2, 3, 4, 5, 6, 7 characters. Then we can try CEPTOF. That's 1, 2, 3, 4, 5, 6 again. EP. This T and T window is breaking things up quite a bit and making it not larger. So I'm just gonna go from O. OFTHE. New D new A new Y. Oh, I think we have a winner. 1, 2, 3, 4, 5, 6, 7, 8. Shazam! All right. So that's the problem. I think I fully understand it. I don't need to walk through all of these. Now we're trying to arrange blocks. Track the character, and this is in the start of the window respectively. Sounds like a plan. I know return is going to be the last thing. That's for sure. Traverse the string character by character. For each character, the hash map does not contain the current character stored its index. If it contains it and its index falls within the current window, a repeating character is found otherwise stored in the hash map with this index as a value. When a repeating character is found, update the start of the window to the previous location of the current element and increment it. Also calculate the length of the current window. The length of the current window is greater than its current value. Just submit. Yeah, sure. Oh wow, I got it. How about that? Good story, bro. And then let's hop into the solution real quick. Again, we're building our index of solutions so that when we see new things in the future, we will know what to reference. Explore all possible substrings. So the naive approach, we do what we usually do, which is to explore all possible substrings. And for each substring, we check whether any character in it is repeated. After checking all possible substrings, the substring with the longest length that satisfies the specified condition is returned. Now the total time complexity is O of n cubed, and here's the breakdown. To explore all possible substrings, the time complexity is O of n squared. This is a common pattern in naive solutions. And to check whether all characters in the substring are unique or not, the time complexity is approximately O of n. So total time complexity is O of n cubed, and the space complexity is O of the minimum between m and n, where m is the size of the character set and n is the size of the string. Cool story, bro. Let's go on to the optimized approach using a sliding window. Alright, instead of reading this wall of text, that's the optimized solution. Huge wall of text. I'd prefer we look through the slides. So you can pause in each case and understand. We're given an input array of characters. We traverse over the array using a hash map to maintain the latest indices of each character. Current length and longest. Keep track. Current length and longest. Keep track of the substring lengths. Cool story, bro. In all the coming size, purple is the current window color. Blue is the index being considered. Yellow is for indices that are no longer in the current window. Alright, let's go. Since the current character is not present in the hash map, we add it to the hash map and store its index. Yay. So A is at index 0. B is not there either, it's at index 1. C is a 2, it's not there. D is not there either, it's a 3. B is, we meet again. Let's repeat it. We update its corresponding value to the latest index. Okay, so now B is no longer at 1, but at 2, 3, 4. So B here should change to 4. Yep, should change to 4. Boom. Then we update the current length with the length of the substring, and the longest with max. Longest versus current length. And the next substring starts after the last occurrence of the current element, in which case now starts at 2. So we skip this, since B is already in that substring, and pick it up from C. So the current length is 1, 2, 3, 4. The longest length is 4. And we carry on, keep calm, and carry on. Now we're evaluating E. We've not seen E before, so we update the list, the hash map, and now we read A again. And we have seen A before, so therefore we have hit a collision. We have hit a repeating value. Since the current character last occurred before the start of the current substring, it is not repeated, and therefore we add it in the substring. Okay, we check because it fell before the current window. We've seen it before, but it's not in the current window, so it's not yet repeated in this substring. So you can add it to the substring, and we have a winner because this is longer than 4. Update the current length, yada yada yay. It's now 5. And since we've reached the end of the array, we return the longest substring length, CDBEA, length of 5. Hurrah! Onwards to the solution. Alright, we have the solution here. We're gonna take note of significant events. Branches tend to be significant events. This guy over here, and this guy over here. Actually, no need for that one, but this guy over here is important. Alright, 3 breakpoints, sufficiently spaced. Probably don't need this one actually. Just go, just 2 breakpoints, and get this show on the road. We want to watch a few variables. We're initializing quite a few things here, so let's just add them to watch. Oh, I need to clear from the last exercise. I need to watch. I need to watch. A current string. Yeah, sure, why not? What is n? N is the total string length. Cool, cool, cool. The longest, we need to see that. Last seen at. Awesome. The current index, I believe. Yep. And current value as a string at a current index. It's the same thing. So I can just add this expression to watch. Is there a shortcut to do that here? Oh, there is. Awesome. And this is noteworthy, an interesting way to do a for loop in JavaScript. What else? What else? What else? What else? Windows start. Have I gone Windows start? Yep. Longest n is the string length. N is not changing anyway. So for every value in last seen at, if it's not in last seen at, then add it, which is what's gonna happen. Defined. So this is our input string, A, B, C, A, B, C, B, B, B. And then we are looking at A for now, right? A is not inside our last seen at, because we haven't seen it yet. We're seeing it for the first time. And so we update it in that map, because, and that's the end of that first loop, right? Because the else statement, the if statement ran, so the else statement won't. In fact, I always favor writing if statements this way. I don't like these I know that they are, it's the same thing, but it's always good to, for me personally, to do things this way. Okay, and then I have to adjust this breakpoint, of course. Or no, kill it and start again. We are good. Let's run it again from the top. Here we're watching the same things. We're in the for loop. Value. Let's see what this says. Last seen at. We know what value is. We know what A. Last seen at is. Last seen at is this guy. So was it not last seen here? True. This is true. This evaluates to true, because value A is not in this, right? It's being negated. Otherwise, it would be false, right? Is the value inside last seen at? False. But then I have this negation that flips it to true. Since it's not added to the shindig, and then the else statement doesn't evaluate, we go to the next thing in the loop. Super simple. Don't let these freak you out. They're not defined yet, right? Because value comes down here, happens down here. So for a second there. This is true again, because again we're seeing them for the first time. So we're building a key of each particular character and its location in the string as the value. We haven't seen C before, so we do the same thing. Now we've seen A before. Aha. We've seen A before, so it's false. Now we're here for the first time. Okay. Is it bigger than or equal to the Windows start? Windows start is 0. Last seen at value is 0. So that is just going to evaluate to true. It's in the window. So the window length is the current index subtracted from the start. The longest. We see this pattern again. I always like doing this. Just helps me think about it personally. Is the longest thing 0? Is it less than the window length? True. So set it to the window length. Now it's going to be 3. So now longest is 3. There we go. And now the next substring will start after the last occurrence of the current element. So we're going to have to move it up 1 from the thing that was repeated. And that thing that was repeated happened at 0, which is A, happened at 0. So therefore, update that. So it has to start from 1, and then update the last occurrence of the element in the hash map. So last CNAD for A has to be updated because we've seen it at 0, 1, 2, 3, at 3. Boom. Awesomeness. Next we are going to, we don't need to see string because we can already see it here. We go again. Index is at 3. Remember the string length is, what is the string length? N. It's 8. So we're at index 3 right now. That's here. This A. We've moved the window to B to start from B, and we're at A right now. We need to move on to evaluate B, which we've seen before. So again, the else statement is going to trigger. Okay, so the last time we saw this was what? Last CNAD was at index 1. Is it bigger than where the window is starting from, or equal to it? Yes, that is true. So move on. The window length is equal to the current index minus where the window is starting. Just 3 again. Alright, let's wrap this up. And then it keeps going on and on and on. Longest was the same thing because longest 3 is not less than 3, right? So that no need to update anything. Then window start is now 2. We've moved the window start from 0 to 1, now to 2 because we've seen B before. And we move on. Ad infinitum. We still haven't gotten here because we're not done with the loop looping through. Now what are we evaluating? B. This second B. I think. Is it the B? Oh, we're at index 5. So 0, 1, 2, 3, 4, 5. C actually. Oh, okay. The val just hasn't updated. We're evaluating C actually. Is it in last CNAD? It's not. Is it not inside? Because it's actually inside. We've seen it. We've seen C before. So therefore, enter the else bracket. Is it bigger? When we saw it last, is it still inside that window? Which is true. Still in our current window. So take note the window length. Update longest if necessary. Now the window start has to shift again from 2 to 0, 1, 2. It's now 3. Update is 3. Then update the last occurrence of C. So last saw it at 5. There are 8 elements in this array. We're at index 6. Run through it again. Again and again and again. We're looking at B. We've seen B before. So same old. Is it last time we saw it was after. So update the window length. You don't need to update the longest because it's the same. The window start is now at 5. Yeah, it was at 4 and now it's at 5. And then we update the last time we saw B, it's just 6. And on and on and on. Just keep going, same old, same old, same old. Because we're at index 7. It's the last time this loop will run. Should be the last time the loop runs. Yay. Now, update. Like, as my custom is, I like things looking a certain way. So if the longest is less than the index 8 minus 7, so 1. If it's less than, it's not less than. 3 is not less than 8 minus 7, because the window is now pretty much at B here. Which is basically checking the last, like a longer version of this, as it seems. The last window, the very last window. Return longest. It's 3. Alright, cool story. Let's look at time complexity. It's giving O of n. O of n, yeah. So, the traverse the input string, use a hash map, store elements and their respective indices. If it is present in the hash map, check whether it is already present in the current window. If it is, we found the end of the current window and start on the next. Check if it's longer than the longest window seen so far and update it accordingly. Store the current element in the hash map where the key is the element and the value is the current index. At the end of the traversal, we have the length of the longest substring with all distinct characters. Yay! N elements of strings, O of n, space complexity. We need space to store the last occurrence of each element. Worst case, while everything is unique, store n elements, diverse space complexity with O of n. And with that, we've come to the end of this session. This is nice. Links and everything else necessary will be in the description. Like and subscribe, share if it was helpful to you, and see you next time, where we will be covering the minimum size subarray sum.